Welcome to Riffing on Knative and sticking around towards the end of the conference. Definitely appreciate you showed up. This is the third in a series of talks that we've had on Knative and Riff. So just out of curiosity, who attended Mark Fisher's talk yesterday just about Knative in general? Great, that's most of you. And who attended Dave Sayer's talk yesterday as well about Spring and Riff? Good. Awesome. All right. So this is a talk focused on Riff, which is built on top of Knative. So we will definitely be mentioning Knative, but this talk is really focused on the Riff user experience on top.
Okay. Who are you, by the way?
My name is Scott Andrews, and
I'm Eric Botta. We're both working on the Riff project and contributors to the Knative project as well. So let's get started, I guess.
So standard disclaimer, I'm sure you've already seen this. We're talking about code that's in alpha. It's going to be changing. So just keep that in mind. And just our own personal disclaimer is just that have functions.
Have functions, yeah.
So this is going to be a demo-driven talk. If the font is too small, I encourage you just to move up a little closer. There's plenty of seats in the front.
So what are we going to show today?
So
quickly.
What we're going to do is we're going to start with just a blank Kubernetes cluster. Okay. We'll install Riff into it. We'll build and deploy a couple of new functions. We'll wire them together. So we'll invoke those functions both as commands, as well as we'll have events that trigger those function invocations.
Okay, let's see if we can do that.
All right. So there's some tools that we'll use. So if anyone's following along later, you can figure out where we got these tools. The most interesting tool, of course, is Riff, which is at github.com/project Riff.
How many of you are Kubernetes users in the room? Okay.
Okay. Good. And who's used Riff before? Just a few. Perfect.
Okay.
So what is Riff? But before we can really talk about Riff, we should take a moment and talk about Knative. So Knative is a Kubernetes-based platform to deploy, build, and manage modern serverless workloads. So what that really means is that there are three different components of Riff. There's build to take source. There's serving that basically manages requests and scaling. And there's eventing that basically has buses and channels and subscriptions. And these are all the components of Knative, but Riff packages them into a single suite that we test all together. So basically, we're doing the integration of everything, so you can just think of them as a single cohesive unit.
Okay. And so that Knative project, it's available to everyone to use, to install on the Kubernetes cluster?
So everything we're going to show is open source. The Knative project was created by Google. They launched it at Cloud Next back in July.
July, yeah.
I think it was July. Time's been fast. And we've been working with Google since earlier this year on the project, along with other industry leaders.
So how does Riff and Knative relate, really? Because I've been working on Riff for a while. I remember there was CLI, the concept of invokers that turn source code into functions. Is that still relevant?
Yeah, so last year at SpringOne, we announced Riff. And really what we've been doing since then is actually over the summer, once we learned of the Knative project with Google, we actually replatformed Riff on top of Knative. And what that means is that for Riff, we were able to increase our own value line by pushing a lot of the plumbing and internals down into Knative. And where Knative had gaps that we needed, we actually contributed a lot of work. So for example, on the eventing layer, specifically for the buses, channels, and subscriptions that we're going to show, between the two of us, we've contributed about 90% of the code.
Okay, so those concepts in eventing really originated in Riff in a way, and they were ported there.
Yeah.
And so a broader community can benefit from them and contribute to them. Yep. That's pretty cool. Okay. Let's move on. And so what's really different between Riff and Knative?
So Riff is really an event-driven function as a service. So that really hasn't changed since last year. The user experience is essentially the same in terms of having invokers and having a CLI that you can use to deploy functions and invoke them. But Riff is also an opinionated experience on top of Knative. There's a lot that Knative powers and provides that Riff either has opinions about and manages for you or exposes.
Okay.
But really the key element of Riff and what makes a function unique in our minds is that functions really are the epitome of inversion of control. So what that means is when you're writing a function, you're just expressing logic. You don't have to create a server. You don't have to bind it to a port. You don't even have to deal with HTTP. You just focus on your logic. And we'll show a couple functions that really kind of drive home how simple it can be.
OK. So let's get started, I guess. So I have a Kubernetes cluster. I could work with a local cluster like Minikube, but it turns out I have a GKE cluster already set up. So this is how you would set one up. For mileage may vary, but I've done that already. But I don't have riff. What do I need to do that?
Yeah. So let's actually switch to a command line.
OK.
OK. So we have a cluster. We're already able to talk to it. We could have created a new one, but we'll save a few minutes.
OK.
Sorry.
On the right-hand side, I'm listing all the pods in my cluster, so you can see it's bare Kubernetes cluster, and I'd like to install riff. What should I do?
So the first thing we want to do is we want to install the system. So if we use the riff CLI.
OK. So I have riff. I'm using this version, latest release, I think.
And that was released on Friday.
OK.
So what we want to do is riff system install.
Riff system install. OK. Just that?
Yep.
OK.
So what this will do is it'll basically go download the riff components and install them. So before it can install riff, it has to install Knative. One of the dependencies for Knative is Istio. So Istio is what provides the service mesh that allows us to do routing and surgical load balancing between different revisions in the cluster. So it'll take about a minute to go through and install everything.
Yeah, I've heard it's a lot of resources, lots of
so
to deal with, but this is all packaged for me, right? So I can,
as you see, just riff system install. So what we can see is in the top, it's actually going through and it's installing Istio. So as Istio is coming up, it'll just take a minute for everything to come up, get its IPs allocated.
So Istio has its own namespace, right? And I'm doing that on my cluster. So it's making sure that everything is correctly started. That's cool.
It's always a little bit slower over conference Wi-Fi, it feels. Demo guys hopefully will be with us.
Yeah, it's going on. And so that's for Knative, right? Istio is part of Knative.
Yep.
And I guess there are other things that need to be installed.
Yep. So it looks like Istio just finished. So now it's actually going through and installing Knative serving. So that's the component that actually manages the actual deployments of functions, and we'll scale it based off of requests.
OK, so again, dedicated namespace, as I can see. And so this is my cluster. I'm only going to do that once, obviously, right? OK.
Well, until you decide to delete your cluster or create a new one.
OK. So it's,
OK.
It's
so
done.
now we're done.
Cool.
So the second thing we need to do is we need to initialize the namespace. So Kubernetes has multiple namespaces. Similar to Cloud Foundry, you have an organization and a space.
Sure,
so what we need to do is we need to install a couple things into that namespace that we want to use.
OK,
so
I'm usually using the default namespace. Is that OK?
That's great.
So
what we can do is riff namespace init. The name of the namespace.
So default here.
And then the last thing we need to do is we need to provide it credentials. Because one of the things that we're going to be doing is building containers inside the cluster. So we need the credentials to be able to push those containers into a container image registry.
OK. Yeah, I've done that already. I've got a JSON file with a
so if you're using GCR?
Yeah, I'm using GCR.
OK. So what you can do is --GCR and give it a path to your credentials that you've downloaded previously.
OK. Yeah, I know where it is.
And this is the hardest part of the install. If you look at the riff getting started guides, it'll take you through the process step by step. In addition to GCR, we also support Docker Hub.
So it's basically easing the process for me.
Yep.
OK. So creating secrets, stuff like
Security is always slightly harder.
that. Always.
So now we should have a system that's up.
OK.
So let's create a function. Do you have a function you want to deploy?
Yeah, someone wrote a function for me. It's in JavaScript, so I don't really understand.
I like JavaScript.
Yeah. So my boss asked me to compute the squares of numbers. So I've got that code.
It's an enterprise technology problem.
It is. I've got that code. It's not big. Is that OK? I mean, it's just.
Looks like you're taking input, you're squaring it and logging and returning.
but there's no...
Is there anything else in this repo that we should know about? Is there?
I don't know. Again, I was handed that code.
So you have a license file, you have a package.json. That's all pretty normal.
So it's just that is my function.
Yeah.
And it's going to work.
Okay, let's try.
Okay. So what do I need to do? Maybe we can cut that off and focus on something else. Let's see, pods in the default namespace. So there is nothing. Okay.
That's good because we haven't done anything yet.
Okay, so what do I need to do to turn my function, its source code
So we have a riff function that we want to create. So how about riff function create?
Yeah, I think I'm getting it.
And then we need to tell it what runtime we want to use. So in this case, you said it was a node function.
It's node.
So let's tell it it's node.
Node, and it's for computing squares.
Yeah, so we give it a name.
Could I call it square?
That would make sense to me.
Okay.
So now we need to tell it where to get the source.
So it's on GitHub.
Okay, so we can pass in a Git URL.
So it's
Git repo.
Git repo, and then the URL of the repo, right?
Mm-hmm.
I think it's there.
Node square.
Yeah.
Yep.
Okay.
And then we need to tell it, because it's going to take the source code, it's going to compile an image from that and publish it. So we need to tell it where to publish the image. So we set up credentials for GCR, so we should probably publish it to GCR.
Yeah, I've got my own project there, so I use gcr.io. And
what do you want to call it? Yeah.
Square?
Sure.
Okay.
Then the last thing we can do, if we run this right now, it'll basically just kick off a process and return immediately to us. But if we want to be able to watch the output, we can just add the verbose flag. We can actually see the output as it's building.
Shall I also tell it where the actual function source file is?
Yeah. So it looked like there was two files. There was the square.js as well as the package.json.
Yeah.
So you could actually specify either of them. But
okay. So what do I use?
So you just specify the artifact.
Artifact. And
so you could say square.js.
Okay. And that's it?
Yep.
Okay. So it's creating some stuff there. There is a pod.
Yeah.
With init containers.
So this first pod it's doing, it's actually creating a build. So this is a build that has a series of steps. So what you see is the pod is initting. So it's at 3 or 4 right now. So as we see the logs, this is actually, it generated a Docker file based off of the image, and it's actually using Conico to actually build it. Some of the other language runtimes use build packs with the new cloud native build packs that we talked about at the conference yesterday.
Okay.
So over time, we'll be switching from this current build over to everything will be build pack based. Now we see the function starting up, and it returned. Okay. So now we have a function running.
Okay.
So let's invoke it.
I see. So just before we do that, I see there is the pod for my function, but there are 3 containers.
Yeah.
How's that?
Yeah. So within Kubernetes, you can have basically multiple containers inside of a pod. And one of those pods is the user container. So that's where your code lives. Okay. Istio also has a container. So the Istio Envoy sidecar will be running alongside your pod, or inside of your pod, alongside your application. And that's what actually allows traffic to enter and ingress through the service mesh. Okay. And then the third pod is actually something that's used to help normalize traffic through the autoscaler.
So it's all taken care of for me?
Yep.
Okay. So I'd like to try that function. What could I do?
So when we created the function, we see here that we have a service that it created called Square. So everything internally inside of Knative is deployed as a service.
So when you say service, you mean Knative service?
A Knative service.
Okay, so what's that? That's like an application, right?
Yeah.
Something like a...
Yeah, it just defines both the workload and a route of how to talk to the application.
Okay.
So this is something that the riff CLI created for us. We don't really need to worry about it. But what we can do when we invoke it, we can say riff service invoke.
Okay.
And then the name of the service,
so
which is Square.
Okay.
Then we need to actually tell it what we want to invoke it with. So in this case, we're uploading a number. So we can say --JSON.
Okay.
And then
it's like curl, right? So I can pass arguments.
Yeah, so if you do a -- and then everything after that is basically just curl commands.
Okay.
So you can pass data the same way you normally would with curl.
-d.
Yeah. So do you have a number you like?
I usually like 7.
7, okay.
Maybe I can use that.
Okay.
Shall I do that?
Yeah, and then, yeah. So what we see is...
it's actually doing curl.
Yeah,
okay.
We'll actually print out the curl command that we're going to invoke for you. So what you can see is in this riff service command, there's really a couple things that we're doing for you. The first thing, we're resolving the ingress IP address for the cluster. So we haven't set up DNS, but we can still talk to the cluster because we resolved that IP address. And the second thing we do is we resolve the host name for that service, and we pass it through with the host header.
Okay, so that riff service invoke thing is really just like a little helper so that I can see.
Yeah, so in the real world, you would not deploy riff service invoke to all of your users. This is really a debugging tool.
Okay, good. And so it's really that curl command, right? So if I do it again, if I manage to select it, come on. It's literally what happened. That's good. Okay. Okay.
And we can see they've got the response of 49, which I believe is the square of 7.
I think it is.
Good.
Yeah. Okay. Maybe it's time to go back to the slides and see where we're at. So we installed riff. Obviously, the cluster thing, I do it just once. And if you have several namespaces or maybe several teams that use namespaces or one namespace per user, you would do the namespace init several times.
And also, each time you namespace in it, you can give it different credentials. So users don't necessarily be able to clobber each other's images.
Okay. So we had that function. I think we used that already. And yeah. Let's see now how we can maybe wire it with events.
Yeah. So before we can do events, we need to create channels.
What are channels?
So a channel is just a named topic that lives on a bus that you can send messages to, and then you can subscribe to it.
So I need to.
So one of the things that we did when we did the riff system install is it installed a stub cluster bus for us.
A stub cluster bus?
Yes.
Tell me about it.
So it's a cluster bus because it's a cluster-wide bus.
Okay.
And the stub bus is basically an in-memory ephemeral bus. It's really useful for testing. It's really easy to just get communication going. But if anything goes wrong, if for any reason the request fails, if the function fails, the message is lost. So there are other buses available that have durability, that have retry, that have other additional capabilities. Okay. But for today, stub should be good enough.
Yeah, so stub is the one you get when you do the basic install. Okay. And you said it's cluster scoped?
Yes.
I assume there are also namespace scoped buses? Okay.
So let's create a channel. So we need to
we
need to get a channel that we want to subscribe the function to. So that channel.
Numbers.
Yeah. Okay. Let's call it numbers.
Okay.
And now we need to tell it what bus we want it to live on. So we said that there's a cluster bus named stub.
Okay. So cluster bus, and the name of the bus is stub. Okay. That's easy.
And then we should also create a channel where we want to send our output.
So the square numbers, you mean?
Okay.
Okay. So should I call it like maybe squares?
That works good for me.
Same thing, same bus, I assume. Okay. Good.
Okay. So we have two channels created. We have a function created, but we need to actually wire them up to talk to each other. So we do that with subscriptions.
Okay. So I create a subscription?
Yep. So riff subscription create. And we need to tell the subscription what channel we want to receive messages from.
So
so if we want to.
Numbers.
Yep.
Like that?
Yes.
Okay.
And then we need to tell it what the subscriber is. So we want to send the message with those events to Square.
Okay.
So the subscriber.
That's the name of my service or my function, right?
That's the name of your function, yeah.
Okay.
And then finally, we need to tell it where we want to take the output from that function and where we want to send it. So we just created the squares channel. So we should reply to squares.
That makes sense. That makes sense to you so far? Good. Okay. Should I just?
Yeah, go ahead and create it. Okay, so there's one last thing we have to do before we can actually invoke it, message-driven. So functions are exposed to the public by default.
Yeah, we just invoked them.
We just invoked it. Channels are not. So channels are intended to be messaging constructs within the cluster. So you can't directly put a message onto a channel.
Okay.
So we need to have some way of deploying a message on a channel.
We could use another function or another app.
Or a service.
Okay.
Yeah. So we have a service that we've been working with just sort of as an experimental proof of concept called the correlator.
Okay.
So if we create a service for a correlator.
So what do we do?
So if we do riff service create.
But previously I did riff function create.
Yeah. So in this case, it's actually not a function. It's a service.
What's the difference?
So the difference, a function doesn't work with ports, doesn't work with servers, doesn't work with HTTP.
Okay.
It's just logic. So in this case, we need to do more than just responding to a single invocation. We actually need to be able to accept traffic at different URLs, different paths,
Okay, so
different headers.
It's aware of
so it's more
HTTP.
involved.
Okay, good.
Yeah.
And do I build it from source or?
Yeah. So what we want to do, we can give it a name first.
So correlator.
It's correlator. And then we need to give it an image. So instead of doing a Git repo like we did before, we give it source. We actually have a pre-published image, so we just need to pull down that image. So we just do -- image.
From an image, okay.
Yep, and then we have it published as project riff/correlator. Project. And then we have a tag on the image called S1P 2018.
Oh.
Just to make it more obvious that this is demoware, but this is the one part of it that doesn't ship with Riff.
And so it's going to create another service.
Yep, so we should see it popped up on our list. So it's created a service, it's creating a pod, and that pod is now running.
Cool.
So what we can do is now we can invoke that function, the square function, through the channel, through the correlator.
Okay, so something like that, but
So-
for the correlator, right?
Yep, so that's invoking the function directly.
Okay. Oh, it
Where-
went to sleep, so it's waking
Scaling back
again.
up.
Okay. And we're going to do that for the correlator as well.
Yep. So what we can do is we can do a riff service invoke
Okay.
to the correlator.
So yeah, I took the liberty to have the logs of the function on the upper left, and we'll see what happened, I guess. So riff service invoke correlator.
And instead of just invoking the function bear, we actually have a path that we need to pass. So we need to tell it where to pass the message, what channel to pass the message to. So we want to send a message to the numbers channel.
Numbers, that's the input, yeah.
Yep. So we can say the path is numbers.
And this is because this is how the correlator app has been implemented.
Yes, this is purely just an implementation detail of the
Okay.
correlator.
And we're going to send it JSON again.
Yep, still sending JSON. And we can still send it the same value we did before.
This is getting old. Okay.
Yeah. And this time we should take a look at the request. So you want to make it verbose?
Bravo. So dash V in
Yep.
Perl lingo.
Yeah,
That's
so
it.
let's invoke it. Let's see what happens. So we didn't get a response.
We didn't?
We got a 202 accepted.
Okay.
So
But the function was invoked. You
Yeah.
can see it from the logs. Okay.
yeah, so the other thing that channels do, it's not just a matter of invoking a function through a channel, because we took the reply from that channel, from that subscription, we sent it to a different channel.
Okay.
So
So I can't see it.
yeah, so when you send a message to a channel, the channel gets it, and then it basically returns a 202 saying, I've got it. So then it's the channel's responsibility to forward that message on.
Okay. Okay. I think
So-
I get it, but maybe let's switch back to slides and see if I got it all right. So we had the square function. We created a channel named numbers that ultimately we wired in a way as the input to square. We had another channel named squares, and again we wired that using the subscription.
Yep.
So the intent is that the data will flow from here to there, but we had to use, given that we're outside of that cluster, we had to use a correlator app that we can invoke directly, but that can talk to the numbers channel.
Yep.
What happened? Okay. And so I made a request.
We made a request, and we know it got to the square function. We just didn't get a reply.
Okay, we have a 202 reply, but
Yeah.
we don't get there.
Okay.
Okay. Good.
So let's do something with that square output.
What shall we do? Do we want to maybe add another function?
Yeah, let's do it. So you have another function available?
I do, as a matter of fact. This one I wrote myself.
So it's not in JavaScript.
It's not in JavaScript. It's actually Bash, but it's like there is literally nothing. It's that.
So you have a repo with a single
Yeah.
file in it, and that file is a bash script with a single line other than the
And
shebang?
it outputs the standard in to standard out, but with L
Okay.
before.
I don't think you can get any simpler than that, a single line function with nothing else. I mean, let's try it.
Let's use it. Okay. So I guess I'll copy paste this. And I can do it as we did before, right?
Yeah. Riff function create.
Riff function create.
So this time we're creating a command. So instead of creating a node function, it's a command function.
So I put command. It's a greeter, so I can call it greet.
Okay. And we still need to pass it the Git URL.
Okay, so Git repo, just as before.
And we still need to give it an image of where to publish.
So I can still use my
So use
registry
GCR, yep.
object. Okay, shall I call it greet?
Sure.
Something. Okay, the artifact.
Yes.
Just
So
as before.
I think you had it as greet.sh.
Greet.sh, yeah. And do we want to see what happens, or do we trust it?
Yeah, let's watch the output just for.
That's it.
Yep. So we should see another service pop up. We should see another build pod as it goes through the build steps. You can see it's initting, so it's already at 2 of 4, 3 of 4.
Okay.
See the log output as
So
it builds.
3 services. Okay, still have my channels and everything, obviously.
Yep.
Okay.
So that's completed, and now it's creating a deployment, and that pod is now running. All right.
Cool.
So we should be able to invoke that function now.
Directly.
Yeah. So if we,
Riff, service, invoke, greet, no particular path.
yeah. So in this case, we were passing text before,
Yeah.
or before we were passing JSON. Now it's greet, so text makes sense.
And this just uses a particular content type header.
Yeah, it just sets a content type. So rather than typing, -h content type, text plain, it's a little easier.
So I can say SpringOne. And what do I need?
Just invoke it.
Just do it?
Hello, SpringOne. So it said hello. So we know the function's working.
Cool.
So, but you wanted to actually do something with them together, right?
Yeah, I'd like the output from the first one to be the input to that one. Is that possible?
And then you want to see the output probably.
I'd like to see the output from the correlator, in one round trip.
Yeah, I think we can do that.
Okay.
Okay, so let's create another channel. So we have a channel that we're sending to, and then we pass it through the square function. We have a channel called squares that receives that riff output. We have a new function. So then we need to create one more channel
That goes back to
after that goes back to the correlator. So let's
the
create a
replies.
replies channel.
Okay.
And it's still on the stub cluster bus.
Okay.
Okay.
Then we need to wire them up.
Yep, so we need to create a subscription to go from the squares channel
Yeah.
to the subscriber will be the greet function.
And the reply to, let
Yep.
me guess, is going to be replies.
That new channel that we just created, yep.
Okay.
And then finally what we need to do, we need to say the replies channel, we need to get those messages back to the correlator.
So we need another subscription
Yes.
from that. Okay. So from replies to the correlator, and there is no reply to here because it's the end of the loop in a way, right?
Yep.
So replies to correlator, and that's it. That's correct?
Yeah, let's get rid of it, yep.
Okay. Good.
Okay. So now I think we're ready to invoke it.
So I had it previously. Let's see if I can do that.
Yeah, so let's just invoke that and see what happens. It should be exactly the same as we had before.
Don't I need to tell maybe the correlator that it needs to wait for a reply or something?
So if you just go ahead and invoke it, we can see that we still get that same response. So we still got that 202 accepted because it by default was going to the channel, and the correlator wasn't told to wait for it. So what we need to do is we need to tell the correlator to wait.
Yeah,
so there's a special header that we can pass.
Okay, I'd like to get that back in my HTTP response.
Yep. So if you go up, we can add a special header called the Knative blocking request.
Knative, I assume dash.
Yep.
Blocking.
Standard HTTP header.
And it's
And then we set the value to true.
Okay.
And if we invoke that,
so it's going to do the same thing, but
it went all the way through because now we got back hello 49.
okay. So what happened here is that the correlator waited for the response on the replatformed channel.
Yep.
Okay, that was pretty cool. Should we recap
Yeah.
that? So we left here. We added a new function. We wired that function to the output of to the squares channel. Added another channel replies and wired that to correlator. And then we invoked correlator, and because it was waiting for the whole trip to finish, we got the response back. Should we zoom in?
Yep.
Maybe?
Yeah, so let's, these are the commands we ran. But OK, so let's take a little bit deeper, just take a minute to just go a little bit deeper. So this is actually what happened inside of the cluster.
Yeah, it's a bit tiny.
OK, let's zoom in.
Let's zoom in.
So as far as we know, we have our client. We made a request to the correlator, and we told the correlator to forward the request to the numbers channel. And then somehow we got a response back.
So
but internally, there's obviously there's more columns. There's more to happen.
Oh, OK.
So if we look at the subscription from the numbers channel, we can see that the channel is making a request to the square function, where we squared the number, got a response back of 49. The numbers channel then forwarded that response to the squares channel.
OK. And this is happening on the stud bus.
Yep.
OK.
So this is basically what happens when you create a subscription.
Okay.
And then from the squares channel, we also sent that message into the greeter, got a response back of hello 49, then took that message, sent it to the replies channel, and got a response back. And this pattern, we can extend it multiple times. We can make these chains of arbitrary length.
Okay.
And then eventually what we do is from the replies channel, we can get a response back to the correlator, which then sends the message back to the client.
And so what happens if an error occurs there?
Yeah, so within these boxes, you can think of them as error boundaries within your application. So if we were using a bus that was more advanced than stub, say like Kafka or Cloud Pub Sub, they have the ability to redeliver messages that failed, unless you acknowledge that you've confirmed receipt. So each of these boxes becomes an error boundary. So anything, if your function is not working, if it's not deployed, it'll just wait, it'll buffer, it'll retry.
OK, that's pretty cool.
Yeah.
So, and at first, we also didn't get the reply back, but I saw there was a weird header with the number in it. Should I care about that?
So that's the correlation ID. So that's actually the magic that allows us to trace the message all the way through the system.
Okay.
So that we know for this particular request, we're going to get back the response that we wanted, not any random response, but our response.
And should I care about it? Can I use it? Can I do something?
So what you could do, and we're running short on time, but what you could do is take that number, and instead of waiting, telling the correlator to block for a response, you could then pull the correlator later with that correlation ID.
Okay.
So whenever the response gets through, then you'd be able to get
I get the correlation ID back, and I can later, if I want to, get the response.
Because if either you might have work that's really slow, or you might have a buffer that you like batch up a bunch of work.
Okay.
So you can just get it later whenever it's done.
Cool. I think we're almost done. But
so I think there's a lot that we didn't talk about. Like we didn't show YAML.
We promised it, so we did.
No YAML. All right. Everything worked. We also didn't show Java or Spring. And we know this is SpringOne. Hopefully people went to Dave's talk and can go back and look at that recording.
Sure.
But
I can use Java functions, obviously.
Yeah. It's also worth, Riff is a polyglot platform. So Java's available if you want it. If you don't want it, that's fine. So there's a bunch of other stuff. You can learn more about it at github.com/knative/docs. So there's a lot more information there. And you can find more about Project Riff at projectriff.io.
Cool.
And any questions, we'll see people up front.
Sure. Thank you very much. And thank you.